Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to graph parabolas, quadratic functions that are of this HK form. So f of x equals a times the quantity x minus h squared plus k. The coefficient, the constant in front of the parentheses, a, that number will tell us whether there's going to be a vertical stretch or a shrink. But also it will let us know whether the parabola will open upward if a is positive or downward if a is negative. The vertex, hk, we can read from the equation itself, the function itself, and then we'll worry about finding intercepts and graphing at that point. So first, this first example, f of x equals x minus 4 squared minus 9. So here, no coefficient, no constant listed in front of the parentheses, so a is 1. That means there's no stretch, no shrink, and it's going to open upward. So first thing I know is that this parabola will open upward. The value of h is 4. That's what's being subtracted from x inside the parentheses. And k is that number written at the end there, negative 9. So 4, negative 9 is the vertex. So I go over to 4 for x, down to negative 9. I'm going to put that on the graph. So there's my first point. Now I know that the graph of x squared, from there it goes up 1 and out 1. So I can get a couple more points right away. But now I'd like to go after the intercepts. And so first I'm going to find the X-Intercept, or intercepts. We know this is opening upward. It's got to cross the x-axis. They have to exist. So I'm going to set the function equal to 0. So set the function equal to 0. So that means we're going to have x minus 4 squared minus 9 equals 0. When you have an equation in this form, we want to isolate the square so we can solve it with the square root property. X minus 4 quantity squared equals 9. Square root of both sides, including plus or minus the square root on the right side. The left side simplifies just to be x minus 4. On the right side, we know that the square root of 9 is 3, so this is plus or minus 3. And then we're going to add the 4 to the right-hand side, and we've got 4 plus or minus 3. 4 plus 3 equals 7. So there is an intercept at 7, 0. Let me put that on the graph. And for minus 3 is 1. So there's another intercept at 1, 0. Starting to take its form. The next thing that we should look for is the y-intercept. The y-intercept is where x equals 0. So we're really finding f of 0. F of 0 is 0 minus 4 all squared minus 9. Inside that parentheses, we have negative 4. Negative 4 squared is 16. Negative 4 times negative 4. So we have 16 minus 9, or 7. So the y-intercept is at 0, 7. Let's put that up there. We can use the fact that the graph is symmetrical around the vertical line, the axis of symmetry that goes through the vertex. And so, just switch colors for a moment. The vertex was at 4, negative 9. So if I look at 4, that point is 4 to the left. I need another point that's going to be 4 to the right of that. So I'm going to move by 4 in that direction as well. Now that's not part of the graph, so I'm going to erase what I wrote. And then I'm going to put the point where I had the arrow right there. And that's enough to get a really good U-shaped graph. Let me start here. Something like that. I'm sure you could draw better on your paper, right? In terms of the domain of this function, It's negative infinity to infinity, all real numbers. And again, that's because we have an arrow heading to the left and the right. There are no values that we cannot plug into this function. The range, though, is bracket negative 9 comma infinity, because it goes down to negative 9, and then it reaches every value above that. All right, that's our first one. Let's try another one. I've got 3 set up for us. The next one is f of x equals 1/2 times x plus 2 squared, that should say, plus 5. So the vertex is negative 2 comma 5, because x plus 2 is really the same as x minus negative 2. And the value for h is the value that's being subtracted from x. A is 1/2, and that means because it's positive that it opens upward, but also that's a shrinking vertical shrink factor. It's going to rise up half as quickly as it did for x squared. Let's start with the vertex. Negative 2, 5 goes here. And what I know is that this function, the graph of this function, opens upward. It's never going to cross the x-axis, because that vertex, that's the lowest point on the graph. So I don't have to worry about looking for x-intercepts, nothing to solve there. I'm going to start with the y-intercept. And the y-intercept, again, we're going to put in 0 for x, and that in this case means find f of 0. So f of 0 is 1/2 times 0 plus 2, all raised to the second power, plus 5. 0 plus 2 is 2. 2 squared is 4. So we have 1/2 times 4 plus 5, which is 2 plus 5, or 7. The y-intercept will not always be 7. Be careful. So I'm going to put a point at 0, 7. And whenever I put the y-intercept on the graph, I like to find its symmetric point, its mirror point on the other side of the vertex. So the line of symmetry goes through the vertex. That point is 2 to the right. I can move 2 to the left of that to get another point that I know is on there. No x-intercepts to worry about, so I'm going to use the ideas of x squared. So the graph of x squared on its own, the next points were at 1, 1, and negative 1, 1. So 1 to the left and right and up 1. But because of the 1/2, we're only going to move up half a unit. So to the right of the vertex, I move over 1 unit, but then up 1/2. And the same thing on the left side, up 1/2. The next point would have been, on x squared, would have been at 2, 4. So 2 to the right, up 4, but half of 4, because a is 1/2, is only up 2. We already have that point on the graph. So we've got plenty here to sketch this graph. The domain, again, all real numbers. The range, how low does it go? It drops down to a height of 5. So I'm going to have bracket 5, comma, infinity. The arrows going up tells us that it increases without bound. One last one of this form. Graph the quadratic function f of x equals negative 3 times the quantity x plus 2 squared plus 8. So the vertex this time is at negative 2, 8. So one way to think of the h part of the vertex, x plus 2 is the same as x minus negative 2. You can also look for the value that's going to make that expression 0. What number plus 2 will give you 0? Negative 2 plus 2 will give you 0. That's another way to find h. I still think it's better if you can think of this as x minus negative 2. K is the value that's added or subtracted on to the end, and here that's going to be a positive 8. A equals negative 3, and that tells me two things. First, it tells me that the graph opens downward because A is negative. and then it's going to move downward a lot faster. That's a stretching factor of 3. So the points will drop 3 times as fast as they would have for negative x squared. Let's start with the vertex at negative 2, 8. It opens downward from there, so I know that there have to be x-intercepts. So I'm going to look for those first. X-intercepts, again, are where the function is equal to 0. We did that on the first problem here. So negative 3 times x plus 2 raised to the second power plus 8 equals 0. We're going to subtract over the 8. Negative 3 times x plus 2 squared equals negative 8. We can divide by negative 3. X plus 2 squared, negative 8 divided by negative 3. The negatives cancel out, and we're left with 8/3. We'll take the square root, and it's going to be plus or minus the square root of 8/3. Now, if we need an exact value, we've got a little cleaning up. We want to rationalize that denominator. But if we don't need the exact value and we're just trying to get this point onto the graph, we can go to the calculator a little sooner. I'm going to show you both approaches. On the left side, we've got x plus 2. On the right side, I need to get that denominator out of the square root, so I can multiply by 3, top and bottom, inside the square root. In the numerator, that's 24, which could be rewritten as 4 times 6, and we know the square root of 4 is 2. So the numerator is going to be 2 square root of 6. The denominator is going to be 3. That's the exact solution. And x equals negative 2 plus or minus 2 root 6 over 3. Those are my x-intercepts. Now, on the calculator, it's actually going to be easier if we use negative 2 plus or minus the square root of 8/3. So I'm going to show you that in the calculator. Then I'm going to show you the one with the 2 root 6 over 3, and we'll see that they're exactly the same. I'm going to start with the addition. So I'm going to start with negative 2 plus the square root of 8/3. And let me switch to the Desmos scientific calculator for this. There we go. Now, the first number was negative 2. And then I'm going to type plus. And then I need the square root of 8/3. So I tap the square root key, the fraction key, and I put in my 8/3. Whoops. I've got to put the 3 in the denominator. So there we go. And I'm going to round this just to the nearest tenth. You can round it to wherever you need to, but negative 0.367 is about negative 0.4, and that should get me close enough to graph this. By the way, let me push enter there, and let me put that on the graph. Next, I'm going to do negative 2 minus square root of 8/3. Negative 2 minus square root fraction 8/3. And there we've got negative 3.633. I'm going to round it to the nearest tenth again. That's about negative 3.6. Now let me go back to the calculator and show you that if I had typed in that exact answer, I would have got the same approximation. Negative 2 plus, now this time I need a fraction. I've got 2 root 6 over 3. So I type the fraction button. In the numerator, 2 square root 6. And the denominator outside the square root is 3. Right, there's that negative 0.367 again. And if I just tap inside of here, I can change that plus sign to a minus sign. And there's that negative 3.633. Right. So We've got the two x-intercepts. Negative 0.4 is a little to the right of negative 0.5 or half. It's going to be about there. Negative 3.6 is a little more than halfway past negative 3 on the way to negative 4. It'll be about there. Let's find the y-intercept next. The y-intercept, we have to find f of 0. F of 0 is negative 3 times 0 plus 2 squared plus 8. 0 plus 2 is 2. 2 squared is 4. So we have negative 3 times 4 plus 8. Negative 12 plus 8 is negative 4. So 0, negative 4 is the intercept. The axis is at negative 2. I go 2 in the other direction. That's going to be about there. Now, the last thing, thinking about negative x squared, which starts at 0, 0, and then has a point at 1, negative 1, and negative 1, negative 1, those have to move down by a factor of 3. So as we move 1 to the side, we're going to actually drop by 3. So 1 to the right of the vertex and down 3 would be about here. 1 to the left and down 3 would be about here. Now we've got a lot of points that we can make this. I'm not sure why that point's not showing up. Presto. So we have a lot of points to connect the dots here with. Let's go ahead and draw that. Something like that. Let's talk about the domain and range. The domain for all of these quadratic functions is a set of all real numbers, but this time the range, it goes up to a height of positive 8, but it drops forever without bound. So this time the range is going to be negative infinity comma 8, and the 8 will get a bracket because that's the highest value that it does attain. All right, those were three different examples of a times x minus h quantity squared plus k. Get your vertex. Think about which way the function opens and will it have x-intercepts, and if you have to, go find those. Use the square root property for that. There's always a y-intercept, so plug in 0 to get that. There's a mirror point on the other side of the vertex that's symmetric to the y-intercept. And then just use what you know about y equals x squared or y equals negative x squared to find some other points on that parabola. All right, in the next one, we're going to take a look at parabolas that are in a different form and how to graph those.